Hello everyone, this is Electroverse. We are here in our three-phase systems laboratory, and today we're going to learn how to calculate the three-phase power of this source applied to this balanced load. And we are going to use the 2-watt meter method to measure the three-phase power. So I'm going to come over here and grab 2-watt meters. I am going to take 2-watt meters and utilize both of them to accurately determine my total three-phase power. Well, this is Blondel's theorem, which states the following rule. If I happen to have a voltage right here, when this principle is applied to a system of n-1 circuits, and we specifically utilize the neutral wire connection, we will then be able to successfully obtain this stable three-phase electrical power output. So here is the load. It doesn't matter if it's star or delta, it just needs to be balanced. It can be delta or it can be star. It has to be balanced. So if I put a watt meter here, I'll have the current coil in series and the voltage coil. I'll have it connected here with the wire which has nothing connected to it. And I'll put another watt meter here, the current coil. I connect it in series, and the voltage coil I also connect up here. Well, so this is the connection I'm going to make. I'm going to come here, I'm going to take a blue cable. And I'm going to connect it here to the current cable. I'll do that first. So I connected the current cable. Now I'm going to connect it here to phase A. Now I'm going to take phase B, white. And now a red one. I'm going to make the connections back here now. Since the load is balanced, I'm not going to connect the neutral because the load is balanced and I'm not going to change that. So I'll leave it, I'll just make the connection back here. And now I'm going to make the voltage connections. I'm going to use a white cable. Well, right now, what I am actually going to do is take this V plus component and move it directly over into phase C. Voltage minus. Now to phase B. Same thing for phase A. I'm going to take V plus to phase A. Now, I'm going to connect V minus directly over to phase B. Well, that's it. Theoretical values. If I apply, I have 250 ohms. If I apply 100 volts, I'll get 0.4 amperes. 0.4 amperes times 100 ohms, I'll get 40 watts. Three-phase 3 times 40. 120 watts. Let's try to prove this. So 102, I'll match it. The power supply is set to 102 volts 3-phase, 250 ohms, and now, folks, look, I have 62 watts on wattmeter 1, 162 watts on wattmeter 2. I have the sum of this 120 watts, which is exactly our theoretical value, so repeating with no volts applied. So, if I'm applying 0 volts right here, I'll have the current passing through this path here. 0.4 amperes without seeing 0.4. I'll have 40 watts on one phase, then I'll have another 40 watts on this phase and another 40 watts on this phase. 3 times 40, 120 watts. This one measured 60 watts, this one measured 60 watts, so I have a total of 120 watts. It's not here, folks, 120 watts in both using the last two methods. So it's proven that only with the 2-wire method, so that's it. And the 2-volt meters, the voltage reference to the same phase that has nothing connected, will give a total, will measure the 3-phase power of the system. Well, that's it, folks. Take care. See you next time.